Hey everyone, this is going to be a bit of a different video on binary here. Usually I'm showing you how to do something. In this video I'm just going to be talking about a couple things about binary. So hopefully you've watched the previous video and you've seen a bit about how binary works. In this video we're going to talk about, well, why is it good, and give you an idea of sort of what it can do and start to do in terms of digital communications. So a little bit from the last video, we saw that binary has only two symbols, right? 0 and 1. Each 0 and 1 is called a bit, okay, which is short for binary digit. If you have 8 ones and zeros, so you have 8 bits, this is called a byte, which is another very common group size for binary numbers, which you'll see why in a little bit. And it's a very common term, right? You heard of megabytes, gigabytes, kilobytes, things like that. You're going to see these numbers pop up in a bit. Binary is good because it can easily be represented in the computer and in circuits. Just to give you a little example here, the piece that really makes your computer chip sort of work, like the fundamental little tiny piece that's always working, is called a transistor. These transistors are very, very, very tiny. You can go read about them on Google, the whole history. They used to start the size of a big light bulb, and now you can fit almost 2 billion of them on a single little chip that would be like a little bit bigger than your fingernail. Okay, so when they make these, which is a fascinating process, right? How they get so many squished in such a tiny space, but when they make them, you have all these little tiny pieces. Now, what do? Basically, they're little electrical switches. And the nice thing about a switch, like a light switch, is the light is on or the light is off, and it makes the light go on or it makes the light go off. This is what's happening in your computer millions and billions of times a second, is these little switches are all linked up in a very fancy way that make your computer work. You can see here if the switch is outputting electricity, maybe you consider that the number 1 in binary. And if the transistor is currently not outputting an electricity, you consider that a 0. So you can see electricity on, electricity off, very easy to represent in binary with the 0 and the 1. You try to do that with the decimal system, it can be done, but it's obviously not as clear cut. Hey, electricity is a 1, no electricity is a 0. Very simple. Hard drive. Your hard drive stores data, basically in binary. There's little magnetic pieces on it. The little magnetic pieces can be aligned a certain way, north and south, and if they're aligned in a certain way, maybe that means it's a 0, and if they're aligned south to north instead of north to south, maybe that means that's the other way. That's going to represent a 1. So very clear cut, right? 0 and 1. Optics. Light on 1, light off 0. There's a lot of other examples here you can go and look up, but binary is very easy because it's so clear cut, right? It's 0 or it's 1. It's on or it's off. Now, common questions students ask at this point as they go, okay, great, you have all these 1s and 0s, but make this a little, bring it closer to home. How can we send like our text messages using binary? Because binary is being sent to send your text messages. So what's going on here? Well, I'm going to show you this one way that's used, popular, which is the ASCII table. Now the ASCII table, I'm just going to click here to show you what it is. It's basically a table that assigns a number to every character that would be on your North American keyboard. So for instance, if I want to send the letter H, what I really want to send is I want to send ASCII code 104. Now don't ask me why it's 104. Somebody sat down, they wrote this table, they picked 104. There's no logic to it, right? H is 104. But you know you can't send 104 because when you actually send this, you're going to be sending binary, 1s and 0s. And so you use what you learned before in binary, and if you had to do the number 104, you're going to come up with this sequence here. Now you'll notice the sequence here has that extra 0 in the front. You don't actually need it, but I'll explain why in a minute you actually need it. One of the little rules with ASCII code is they send the binary in groups of 8. And that's why that we said before that 8 bits is a byte. So this is 8 bits. That's 1 byte, and 1 byte stores one character. Okay, let's say the letter H. You'll see here the ASCII table actually includes more than just letters. It includes the enter key, the number sign, the dollar symbol, the space bar, the delete key, the tab key, brackets, commas. Okay, this is the little short ASCII table just to give you a simple view of it. But when you send this in the groups of 8, basically you get to send your text message. So you'll see here in my notes I said, let's try to send the message hi. Well, that's 2 letters, which means I need 2 bytes worth of data, right? So 2 groups of 8, which is 16 bits, and this would be the H, and then that would be the I. Now you may say to yourself, oh, that's so long, but that is what's happening. Modern computers now and network transmission, very fast. You're sending hundreds of thousands, millions of these a second. Okay, it doesn't matter that there's a lot of ones and zeros. We can send them fast now. It's not a problem. So that's the basic idea with how text can get across. And we'll talk in the future about how you could send music and videos and pictures. What more to tell you here? Just the conversion symbols at this point would be nice. You now know that 1 byte can represent 1 letter, or I should put character or symbol on your keyboard. A kilobyte, well, kilo stands for 1,000. So in the metric system, a kilobyte is 1,000 bytes. So that would literally be 1,000 letters. When you save your Word documents or any document, you can check the file size. Usually something you've typed out is measured in kilobytes because it's pretty well close. It's in the range of thousands of letters that you've typed. Now if you type something really, really, really big, you're going to get a megabyte, which is 1 million bytes in the metric system. And here we have 1 gigabyte, which would be 1 billion. I got to add the right number of zeros there. I think that might be right. Letters. So when you start talking about a gigabyte and you buy these hard drives or these memory sticks and they're like it's an 8 gig memory stick, you're literally talking about 8 billion ones and zeros being stored on that little device. That's how small those transistors and the parts they use are to store the electrical charge. Pretty good. Anyways, that's a little intro there, binary, why it's used and what it can start to do, and a bit about the size.